Most gardeners spend money on bagged nitrogen fertilizers while their plants sit quietly deficient in the one mineral that determines whether all that nitrogen gets converted into growth at all. Magnesium sulfate, the compound in Epsom salt, is the central atom of the chlorophyll molecule, the physiological catalyst behind every photosynthesis reaction your plant runs, and one of the most cost-effective mineral inputs available to any home gardener. A bag of Epsom salt costs less than most single fertilizer applications, lasts an entire season, and addresses a deficiency that silently limits growth in more garden beds than any other mineral imbalance. Conventional NPK fertilizers address nitrogen, phosphorus, and potassium while treating secondary minerals like magnesium as an afterthought. The assumption embedded in this approach is that most soils carry adequate magnesium reserves, an assumption that breaks down in sandy soils with low cation exchange capacity, in heavily irrigated beds where magnesium leaches below the root zone, and in any soil that has received high calcium amendments like lime that displace magnesium ions from soil exchange sites through competitive adsorption. Magnesium deficiency manifests as interveinal chlorosis, the yellowing of leaf tissue between the veins while the veins themselves remain green, a symptom that is regularly misdiagnosed as nitrogen deficiency and treated with more nitrogen, which compounds the problem by increasing the plant's demand for the magnesium it is already short of. Magnesium occupies the central position in the porphyrin ring of every chlorophyll molecule, the structure responsible for capturing light energy and converting it into the chemical energy that drives all plant growth. Without adequate magnesium, the plant cannot synthesize new chlorophyll at the rate active growth demands, and photosynthetic efficiency declines regardless of light intensity or nitrogen availability. Magnesium also activates more than 300 plant enzymes involved in ATP synthesis, protein production, and phosphate transport, functions that collectively determine how efficiently the plant converts available nutrients into biomass. Sulfate, the second component of magnesium sulfate, supports amino acid synthesis and activates sulfur-containing proteins that contribute to plant structural integrity and pest resistance. The combination of these two compounds in a single, water-soluble salt makes Epsom salt one of the most biologically complete secondary mineral inputs available at any price point. Soil application of magnesium sulfate is effective but slower than foliar application because the mineral must move through the soil solution, cross the root membrane, travel through the vascular system, and reach the leaf tissue before it can contribute to chlorophyll synthesis. Foliar application bypasses this pathway entirely, delivering magnesium directly to the leaf tissue where chlorophyll production occurs. Dissolve 1 tablespoon of Epsom salt per liter of non-chlorinated water and apply as a foliar spray during the early morning or late evening when stomata, the microscopic pores on leaf surfaces, are open for gas exchange. Applying during peak daylight hours when stomata close under heat stress reduces absorption significantly. Apply the foliar spray every 2 weeks during active growth periods, ensuring coverage of both upper and lower leaf surfaces. For soil application to address root zone magnesium deficiency, dissolve 2 tablespoons per liter and drench the root zone monthly. Plants corrected from magnesium deficiency show visible improvement within 7 to 10 days of the first foliar application. Interveinal chlorosis fades as new chlorophyll synthesis begins, leaf color deepens, and new growth emerges with the dark green coloration that reflects adequate mineral nutrition. Beyond the visual response, plants with optimized magnesium levels show measurably higher Brix readings, the measurement of dissolved sugar concentration in plant sap, because efficient photosynthesis produces more sugars per unit of light captured. Higher Brix correlates with improved pest and disease resistance because the plant's biochemical defenses are adequately fueled, and because many pest insects preferentially target plants with low Brix readings that indicate nutritional stress. Integrating Epsom salt into a regenerative soil management approach requires attention to overall mineral balance rather than isolated magnesium supplementation. Excessive magnesium in relation to calcium disrupts the calcium to magnesium ratio that governs soil structure and root penetration, The ideal ratio in most garden soils sits between 7:1 and 10:1 calcium to magnesium by weight. Test your soil's existing magnesium levels before establishing a regular application schedule, and use foliar application as the primary delivery method to avoid accumulation in the soil solution. Combined with compost inputs that support the microbial activity responsible for releasing naturally occurring soil magnesium, Epsom salt foliar applications create a mineral environment where every other input the plant receives gets used at maximum efficiency, a compounding biological return that improves with every season of consistent application. Subscribe to Natural Crops and AMP Soil Hub for more evidence-based, low-cost growing strategies that build genuine plant health from the mineral level up. And share this with a fellow gardener still treating magnesium deficiency with more nitrogen and wondering why nothing is improving.